I want to explain why expanding the solar system into multiple suns is going to be so cool. Already, the game is very chaotic. You can be building your own space station, minding your own business. Play for free in the link in the description. There's some wreckage flying by, right? Already, it's just chaotic. Like I didn't place that ship over there. Like I'm trying to build this little space station, and there's just some wreckage idly orbiting the sun that somebody else made, completely player generated. It's like player generated chaos, right? Chaos is actually something you can measure. It's called entropy, and it does straight up like SI units. You can measure entropy. The amount of chaos in a system that can't be like gone backwards from. On the left is in the beginning, and on the right, you just see these bands of color. That's chaotic numbers. Now, adding multiple suns, which are all orbiting each other, is going to add a hell of a lot of chaos. Significantly much more than was so with just one sun that's stationary. A lot of this game will be dealing with this chaos, like in your ship designs and everything. Finding safe spots in the solar system. I do want to make that easier with like orbit computers. But anyways, here we got a screenshot of the game, right? Let's just say this ring is your current orbit. It's kind of like known at a certain point in time where you'll be with one gravitational body. However, when we add two, and I'm assuming the gravitational attraction from the sun to like spaceships is negligible. But as soon as we add two, you can kind of imagine what the gravity might be. It might be some kind of like oval thing. You know what I mean? Like that would be the path you go around these two bodies because they kind of like are like one. But something you're kind of forgetting is that these stars, these suns in and of themselves are moving. They're dancing with each other. And now even so, like you can kind of predict they're just gonna like dance in a circle, right? It's gonna be pretty straightforward. What's going to happen because they're only ever attracted to each other. And if we open the book of nerds and we just look at like the equation for the attraction they have to each other, it's pretty simple in this case. This is the equation. F is equal to G times M1, M2 over R squared. Math is a program, so you multiply the masses, divide by distance squared, and then multiply by some magic number called G that God invents. In this world, I'm God, so I'm going to choose 30. And anybody who says wrong is committing blasphemy in this game. Like with only two cases, the force, right, as long as the distance, right, the masses don't change. You don't have to worry about this changing, but the distance changes. It doesn't change in this case if they're like orbiting in a circle. Now in physics, when you have a force which doesn't change, it's pretty easy. Gravity, like on Earth, might as well be like it's a force that doesn't change. It's always down at around like 10 meters per second squared. It's always pushing down and it doesn't change, right? But like shit starts to get bad when the force changes. It gets real bad, really quick. Because of that, as soon as you add a third body. Work on gravity, but you couldn't attract nobody. I wonder what like a child in Africa would think of epic rap battles of history. Like doesn't leave the village, doesn't know about the world, and you tell him like, yeah, in America they have like these people get paid millions of dollars a year, and they pretend to be like famous people from history, and they make rap songs, and they earn like more than everybody in your entire village will ever earn from all of their entire life's work, times like a million for making those rap songs. But what are we talking about? Gravity. So like once you had a third body, once you had a third sun, right? Like let's just say there's a third one here. If they're all going in a circle, right? The distance still doesn't change, right? But let's say like we put this thing like over here, right? See, now we're getting into some trouble because that's like the distance between these objects are going to change. And so the forces are going to it's going to change. The force is going to change, and it's going to change in a way that's impossible to predict, like provably. So this right here is a simple case of the three body problem. Each blue dot is a sun, right? And it turns out that in an infinity shape, it actually like is stable. It doesn't go haywire. Now here's what it looks like when you have three bodies in a less conventional path. Look at how chaotic it is. You cannot predict where it will end up with 100% certainty. You can only run a simulation like we're going to do in the game. You think three suns is crazy. Bro, do you have any idea how fast computers are? I could have like 8 suns in the game. Like one there, one there, one there, one there, and they're all constantly in a dance with each other. And as the suns move, they're pulling your stations with them. And so this chaotic motion of the suns is like dictating like who is the upper hand a little bit in squad fights. It'd be so fucking cool. And then the suns have different masses too. Something I really want to do. Well, I wrote it down in my notes. I want to create like the orbital cannon from Mander's game.
Seal! Firepex, we're out of time!
You know what I mean? Real power. I think the way it's going to work is you need like a bunch of solar panels, and then you have like this beam block, and it just shoots a beam that's anybody can see always across the entire map forever. and it'll just like melt through boxes like butter. But you can catch it with like an energy catcher to transport energy, something like that. Anyways, that's all I got for you guys today. There's a big playtest tomorrow, 6 p.m. with all this interesting stuff. Join the link in the description to play now. Don't forget to like and subscribe.